Hello class, this is a video tutorial on polynomials part 3. In this video we'll be looking at polynomial equations. When solving quadratic equations, it is already implementing polynomial solving techniques. So if we were given this equation here, what we would normally do is move all the terms to one side and we would get this. From here we would factorize. And then using the zero product rule, we would let each factor equal 0. So 2x plus 5 equals 0, x minus 3 is equal to 0, and solving each as a linear equation. We could have also used the quadratic formula, but we are going to be solving polynomials in the same manner shown here. The reason being is quadratic formulas work for quadratics, but there actually also exists a cubic and quartic formula, so to the power of 3 and to the power of 4, but both are unreasonably long to memorize or even use. So to solve an equation that looks really similar, we would first move all the terms to one side, like so, letting it equal to 0, and now, as we've seen from the previous videos, we've now learned how to factorize polynomials of higher degree than 2. So from here we would test the factors of 6. For this I've already tested 1, so if you substitute 1 for x, we would get 0. So meaning we would do a long division, ignoring 1, multiplying, adding, multiplying, adding, until we get this factorization. Then from here we would factor one more time, factoring this into 2 and negative 3, and we would get 3 solutions. Now factoring may take longer with higher degree polynomials, but as we've seen in previous videos, it's the same method repeated again and again. So let's go straight into it, into an example here. You can pause the video and give this a go yourself. So let's do this. Now, as we've said in the previous videos, if it's to the power of 4, we are looking for 4 answers at most. If this is to a power of 5, we are looking for 5 answers at most. So it actually might be 1, 2, 3, 4, or 5. But cannot exceed 5, and this can't exceed 4 different answers. So for this, let's just test one of the values. Let's test f of 1. So substituting 1 to the power of 4, minus 2 to the times 1 to the power of 3, minus 7 times 1 squared, plus 8 times 1, plus 12. This gives me 12, so this as a factor will not work. Let's test negative 1. Negative 1 to the power of 4, 2 times negative 1 cubed, negative 7 times negative 1, typing it all in, and we get 0. So negative 1 does give me 0. So the first factor we're going to divide by is x plus 1. Grabbing our long division, so we get negative 1, 1, negative 2, negative 7, 8, and 12. Ignoring the first and multiplying. Adding, multiplying, adding negative 4, multiplying, adding, multiplying, and then adding. So f of x is equal to x plus 1. Since this is to the power of 4, the new quotient is to the power of 3, power of 2, power of 1, plus 12. And once again, we're going to try to divide this. Let's test let's test 2 this time. So 2 cubed minus 3 times 2 squared minus 4 times 2 plus 12. This also gives me 0. So since that works, we're going to divide by x minus 2. So 2, taking the coefficients starting from here, so 1, negative 3, minus 4, and 12, ignoring the first, multiplying, adding, multiplying, adding, multiplying, adding. So f of x can be further factorized into x plus 1, x minus 2, and since this started on 3, this is now x squared, so x squared minus x minus 6, and since this is a quadratic, we can factorize that a little bit quicker. I can think of two numbers, them being positive 2 and negative 3. Since we're looking for zeros on this, which is what it's asking for, all that means is we're going to let f of x equal 0. So f of x is equal to 0, which means we take all the factors and we let that equal 0. And as we've seen in the previous example up above, we let each of the factors equal 0. Plus 2 equals 0, x minus 3 is equal to 0, and we solve each individually. X equals negative 1. Bringing these two together, I can just say x is equal to plus and minus 2, and x equals positive 3. And these are the four solutions. X equals negative 1, plus or minus 2, and 3. And those are the four solutions. You can pause the video or start the exercise questions, because I'm just going to go through this one as one last example. So here we go. Let's test the values. G of 1, because why not? 4 times 1 to the power of 5 minus 17 times 1 cubed plus 4 times 1. Oh, actually, I've just noticed one thing here. Notice how they're all x. There is no constant term. That means we can immediately factorize by x. So x outside of 4x to the power of 4 minus 17x squared plus 4. So we already have one factor of x equals 0. Then from here, we check factors of 4. So let's test. Let's let this part be q of x, and let's test 2. So q of 2. 4 times 2 to the power of 4 minus 17 times 2 squared plus 4. This gives me 0. So I'm going to be dividing this by x minus 2. Oh, the parts that I erase, you can just do using your calculator. You don't have to write them out. So we're going to do the division. 2. This is going to be 4. Now remember, notice how the powers skip x cubed. So really, there's a not really hidden, but it's one that we don't write, 0x cubed. We have to always include that as our coefficient of x cubed. Moving right along, negative 17. And notice again, it's missing x to the power of 1. So there's another hidden 0x here, plus 4. So be mindful that you don't miss those as well. Now that we have that set up, long division happens as per usual. Ignoring the first, multiplying, adding, multiplying, adding, multiplying, adding, multiplying, and then adding. So the two factors that we have now for g of x is x minus 2, and this new quotient here. Since we divided from x to the power of 4, this is now x cubed. So 4x cubed plus 8x squared minus x minus 2. Dividing this new quotient once again by a new factor, let's test, so remember that's a new quotient. Let's test, well, since it's negative 2, let's try positive 2 once more. Let's see if there's a repeated root here. So 4 times 2 cubed plus 8 times 2 squared minus 2 minus 2. This gives me 60, so that doesn't work. Let's test negative 2. So going back to my calculator, negative, it's putting negatives in where 2's were. Minus 2, so that's going to be plus 2. This gives me 0. So negative 2 works when I substitute into this polynomial. So what we're going to be dividing by is x plus 2. So that's our factor, but we're going to write it as negative 2, and we're going to take the coefficients of this this polynomial here. So 4, 8, negative 1, negative 2. Ignoring the first, multiplying, adding, multiplying, adding, multiplying, and then adding. G of x can be further divided into x minus 2, I'm just copying this one here, and x plus 2 here now. Our remaining quotient here, since this is this one here is cubed, this will now be squared. Plus 0x, which we don't need to write, minus 1, because there's 0x here. This is nice and simple now, because that I can factorize, because that is a difference of 2 perfect squares. So we can further factorize all of this into, this is a difference of 2 perfect squares, 2x plus 1, 2x minus 1. Now, since we're looking for zeros, we're going to let the function equal 0. So all of this equaling 0, x is equal to 0. I'm going to go straight into the solution, because normally it's x minus 2 is equal to 0, but I'm going to skip straight to the solution now. So we're going to get x is equal to plus or minus 2, as we can see here. 2x plus 1, it's going to be 2x equals negative 1, x equals negative half, and this is going to be positive half. Okay. You know what, I won't skip too much here. This next one is going to be 2x equals positive 1, x equals positive half. All in all are 5 solutions here. Here's 1, here's 2 and 3, and here's 4 and 5. And there are our 5 solutions. So I hope that gave you an insight into more polynomial long division, as well as solving polynomial equations. Hope to see you in the next video. Best of luck.